Oh, no testing. Okay. Why am I off center? Hugely. Okay. This new name, the new little voice comes on whenever I turn the recording on or off. Yeah, Coffee Compiler Club, you're being recorded. Everyone knows this. If you don't like it, bail out. Fine. We've all this before. Yeah. I've been working on this damn integrating type theories for like 6 months or something. Current theory is that, and this is what I'm implementing as fast as I can now, that the Hindley-Milner typing is monotonic in this funny way, and that when you run it, you strictly unify different portions of however the algorithm visits the tree, the AST, you unify. Every unification step is a one step, not really reversible, extends types somewhere. Or it makes no progress, or if it does, something got extended. Nothing changes in place, nothing rolls backwards. So in that sense, it's monotonic. So if I look at the set of algorithms I'm looking at here, it's all a monotonic framework where I take multiple different algorithms that are independently monotonic with transfer functions that are monotonic and lattices that are monotonic, and you just keep applying things till you hit a fixed point, you're done. Okay, so Hindley-Milner hits its own fixed point. Conditional constant propagation hits its own fixed point. They're all monotonic. That should be combinable and also remain monotonic, and therefore hit a fixed point in a finite period of time with a good answer kind of stuff. That's that theory. And it's only useful if you have ways to drag facts from one side of the equation sets to the other, which I now do. So the direction from constant propagation to Hindley-Milner is straightforward on an if statement where you have a predicate. Hindley-Milner would typically say, if predicate, then A else B, unify A and B. They have to be the same type, so the result of the if is the same type. If you know something about the predicate, like the predicate is true only, you don't have to unify the false side. And vice versa. And in the lattice theory, there's a top notion which says it's nobody and you don't unify anything. And then once it falls from top to true or false, you unify the one side, falls to bottom, you unify them both, just classic Hindley-Milner at that point. So that gets you facts from constant propagation into Hindley-Milner to improve the Hindley-Milner answer. The reverse direction is one I've been doing for a while, and I'm only slightly suspicious of it. And that's when you come out of an application in Hindley-Milner, which is a function call, the Hindley-Milner types have already made a fresh copy of things for the inputs that become the outputs. So the input types and the output types in a data flow sense don't mix. And that just says if I have a fact for a call and I pass it into the call when it comes out, it's the same as it was when it went in. And in the classic data flow theory, if I just treat a call site as a merge point, so call graph analysis kind of stuff, all your arguments get merged at the call. They all become the mix of them all. So you approximate like hell and you lose all your facts. And when you come to the exit point, you're returning one of those facts you've already forgotten. You've merged everything, so you have a crappy answer. And here Hindley-Milner will tell you, no, in fact, it's not that crappy. It has to be at least as good as whatever type I have associated with that particular type variable. So separate types from type variables. So flow types from type variables. It has to be at least as good as the flow type associated with the type variable I know that's being returned out. And therefore I can do a join operator, not a meet, and lift the type. And that gets me facts in the other direction. And that's what I'm currently busy implementing. And I've been close to that back and forth for a while and did a bunch of other stuff that got me sidetracked left and right. It's the usual researchy things, cool idea, and you chase and you suddenly discover you've gone a long way down a rabbit hole and it wasn't going anywhere. So I backed off from a number of rabbit holes. The other one I have as a thing that I think I know how to do that got me wedged and I had to back off from was doing memory updates with actual pointer values and aliases and the like. And in the lattice theory side of things, I have a pretty strong theory going. And in the Hindley-Milner side, I was thinking it would be same as structural subtyping, but it's not. And it's not because when you, the structural subtyping says I have a structure, has a bunch of records, the records have types. If I have two Hindley-Milner struct types and I unify them, then you get the union of all the fields within and the fields internally unify. It's all pretty straightforward.
Does this unify only the fields? Can you have a record with unified methods too?
So for me,
we had an interesting discussion by email.
Yeah.
So for me, well, okay, fine. So the methods for me are stored in fields. So it's just unification of fields. So it follows exactly the same rules as unification of fields, right? And then what the method does is whatever the code associated with it, but the method itself is treated as if it were a field. And in my case, it actually is. I mean, I don't actually put storage for it behind it because it's a constant value and I know the value and the value is a function pointer, blah, blah, blah. But from the semantic point of view, yeah, it's a field.
Yeah. As long as I look at about data flow typing, and all their examples are about if and else statements, which allows you to recover more information about the actual check. So we can say that the check influenced the type somehow.
Yeah, I haven't thrown out or not thrown out the notion of an if that has gives you more precision for one of the arguments. The usual, you do a null check, and along the branch you get a null check, it's null or not null. And the other one is you an instance of check, and along the branch we did instance of, well, you can lift the type, and you can lift it in dataflow and you can lift it in Hindley-Milner both. And so that's definitely a thing that I believe I know how to turn on sort of straightforwardly, and I'm busy sorting out why memory, where memory is basically structural subtyping with alias numbers being the new field names and the alias contents being structures themselves. So it's just one more layer of a structural recursion thing where memory is indexed by alias numbers, which alias numbers are just unique per new allocation. You have new allocation site, you get a new alias for it. Fine. I thought that was
reasonable that the values influence the type. If you have some known values that can influence the type. So I believe what this is happening in data flow typing.
Yes.
The actual value influence the output type.
Right. So I haven't had a way that a data flow type tells me something about Hindley-Milner other than don't unify or do unify. That is to say, if I have a struct allocation in the code, both Hindley-Milner and dataflow take it as a syntax only first principles. We both agree there's a structure here of the following general form. But I don't make a structure in dataflow that Hindley-Milner can't see from a syntax. Everyone agrees the syntax says I did a new struct, and that's where you start from for that. The joining operator post call allows me to discover a new data flow facts, but I don't have a data flow fact that would discover a new structural type that Hindley-Milner has. And Hindley-Milner will eventually come around to unification, that he'll come to the same set of structural types that they're apparently programmed. Like structural types are always apparent in the program. Let me add a guy here, and then Peterson, there it goes. The failure I was trying to get around to for memory as a structural subtyping using aliases is that it doesn't work because pointers can share multiple aliases, and there's no way, and so therefore when you come to the unification step for memory and I'm unifying with an alias number, in the structural subtyping, it's always a known field name. I did a load or store of a field. The field name is syntactically there, just completely, I know it's the field called .x or .Persian or whatever the hell. And in the aliasing, it's a variable. I'm aliasing those things from new allocation sites 5, number 17, and number 21, or whatever they were. And the data flow type, I simply propagate the bit vector containing this set of things that are embedded in the Hindley-Milner. That's not a variable in structural subtyping. So it'd be structural subtyping, except your labels are variables now. And that one I didn't know how to do. So I backed off from that one. Then I figured out that because of the monotonicity on the data flow side, that I can just take the ever increasing set of aliases that would be available to the data flow, like he keeps discovering new aliases, and force more unifications. But you lazily force them, and it's just the same as the if then else hack, where first you unify nothing, and then the predicate becomes true. So you unify the true side, and it becomes true or false, and you unify both sides, and you monotonically increase your unifications as you go. So I believe it will fold together nicely, but it's not, I don't get variables in the, I can't have variables on the memory unification side from the Hindley-Milner sense of a type variable. I don't know how to do that.
Yeah, with the meta type variables, they will bind all together. I've seen it that the meta type variables that used to hold the type will, I believe it can bind the information from the lattice and information from the Hindley-Milner. There's some kind of a central point.
There is a thing that says when I unify two Hindley-Milner types, and I'm carrying along with each one a lattice type, I have to do something now, right? And the two lattice types have to be unified. And the easy answer is, well, I'll just do a meet because both facts have to be true. Except that I get a complicated Hindley-Milner type below this point, for which I now have to decide what to do with my complicated lattice type here, which should be structurally equivalent. And I think I need to distribute it down through Hindley-Milner. That's sort of the current open question, is implementation strategies.
So is it that becomes an or? This is either memory allocated at site A or memory allocated at site B?
Yeah, it depends on what you define for or. In the land of everything symmetric, I always have them inverted from what everyone else believes they want to hear. You have to support that it's both. It could be this, or it could be site A, or it could be site B. So call that a meet, call that an or. I mean, I call it an and. I say it could be A and it could be B. So I have to claim them both.
Right, but the thing that seems scary there is, what if there's a lot of different places that can all meet there, and you end up with this like
giant wad?
Yeah.
Yeah, right. So in Hindley-Milner, you would end up unifying all those things anyhow, because they're all one at a time. So you pay the cost unification one per. And that's what I'm going to do on the data flow side of things too. You pay the unification cost one per.
Yeah, it's not terribly expensive though. I mean, it sounds expensive, but we're talking very small numbers.
Yes.
Like even the worst case scenarios, unless you've got some sort of metaprogramming capability, the numbers don't go up exponentially. So C++, you're fucked, but everything else you're fine.
That's interesting. In the land of Hindley-Milner, it's well known that Hindley-Milner is like cubic in the worst case, and I can pull out the example that runs cubic, but it's nothing you would ever write in code. And in practice, things that you write in code go linear. And that's my example. That's my test case too. So I get heavy profiling going on in this stuff, and I'm counting every allocation of a Hindley-Milner type that unifies to whatever. And I've done some cool shortcuts to make the algorithm run faster, some memoization, shit like that. And the answer is basically it's linear. It's very close to linear until you run these exponential things. And I just have one lying around here because you have to have it just to know that this is where you get fucked. Yeah, okay, here's the, throw it into the chat here. Here's the example where you keep making a function which takes an XYZ and it produces a thruple, a 3-pack of a function which takes the 3-pack of that and model. And what are the types involved? And the answer you get out for what the hell the type looks like is this, which I will also dump in the chat, and you can see the growth here. It's like pretty ugly, right? And I pulled this out of Stack Overflow. You know, hey, what's the worst case scenario? Well, this is the worst case scenario, and here's the example. It's like, sure enough, bam.
That really doesn't look bad.
Well, but obviously,
give up and say,
yeah, it's cubic in theory or something. It's something horrible.
Yeah, the compiler will throw the type.
cubic is bad, but I would rather have something infinite. So I'm just going to make this thing a recursive type that's self-referential. And now it's infinitely big, but sometimes infinity might be smaller than cubic.
Yeah. Right, exactly. That's right. So that would say that I could approximate my Hindley-Milner types at some point and just say, we don't fucking care, infinite.
Right. If I have factorial of a billion, in theory, you could keep unwinding that forever in your constant propagation, but eventually you just stop and say, you know what? Eventually I stop.
Yeah, constant propagation has a widening operator exactly for those situations. If you have a range, if you just do ints, then it's just ints and ints, and you don't. But if you do more than constants and then do a range, then the easy one should for I equals 1 to n. Well, I starts at 1. Now I is 1 to 2, I is 1 to 3, I is 1 to 4, and it runs forever. So you widening operator. 1, 2, 3, many. And then you're done. This is what I call caveman counting. 1, 2, 3, many. And that's it. So that's my excitement. I'm busy getting my data flow types to flow through Hindley-Milner without breaking, without doing anything fancy with them. And then I'm going to take my data flow types and make them do CCP on this very trivial language I have, and make sure the Hindley-Milner doesn't blow up. And then I'll start the bidirectional interaction, look for test cases that I can do something exciting with. In particular, on the full AA language, I've been running the Hindley-Milner types back into the AAs and the data flow side for a while now, and that seems to work. It seems to rescue me from all the usual. It gets me back to strong types after meets and joins that are stronger than Hindley-Milner, because I have that going, but they're at least as strong as Hindley-Milner. So I think this one's, I think it's doable.
We will do it.
There you go.
Yeah.
No. TDR has been piling in. Cameron's actually been piling in too here, but between you two, I've been getting interesting reading material. And Theodore, I'll just throw out the thank you and the ML sub. Okay, the ML sub discussions are really good. Actually, I'm just going to copy these. This is a nice set of videos and what I've been watching to describe sort of the basics of where I come from. And the other thing, this SSA paper you threw out, I don't know how to throw this attachment into, can't throw it here. Fine.
I think I gave you a link to it, didn't I?
No, I'm talking about for TD, or gave me a SSA-based flow sensitive type analysis, which is basically like halfway through my thesis. It's like what I was doing in my thesis. I'm doing flow sensitive SS-based type analysis. That was my, PhD thesis. So this is basically, I don't know if this was, here's the paper, but where does it come from? And I don't have a link. I have a title, and I bet you if you Google it, you guys can find it, and it's not a problem.
Yeah, sure.
So I read it through, and it's like, yeah, okay, this is my thesis work. But, I don't know if it references my thesis or not. He's just doing, for what I'm concerned, standard jump. So I say thesis work, but I didn't, this is fair enough. In my thesis, I didn't go down the point of doing a call graph. In C2 and hotspot land, I started doing call graph shit. Right now in AA, I do call graph shit all over the place. So yeah, okay, right. So he's referencing my thesis in there, but I didn't actually write that out specifically. But I've been doing call graph shit for a long time, and it's just straight up. It's just like another form of control flow. You have to deal with the infinite return stack hack with some sort of approximation, and otherwise you're done. Yeah, fine. I won't go any more on that one. Where's Matt? Yeah, exactly. Fine.
Looks like Aaron found the link.
Yeah. So there's my status dump. Here's my other status. My last remaining child is off to college this weekend. Yeah, exactly. Oh my God. Been a long time. My middle two are doing better. They're not quite languishing around. They're actually starting to maybe move, not going to plastic.
Do you teach them programming?
There's only, you can lead a horse to water and you can't make him drink, right? So if they're not interested, they are not interested. Anything but what dad does, right? So that's it. I couldn't teach them to drive a car. I love driving a car. I claim I'm good at it. I've tracked a car for a while. Okay, fine. They would not learn to drive a car. And I think that's just because they didn't want to.
They didn't want to learn to drive from you, or they didn't want to learn to drive at all?
I think they didn't want to learn to drive at all because they wouldn't meet my expectations. In their head, they wouldn't meet my expectations of what they imagine I would expect of them as a driver. I was a starter driver at some point. I've seen plenty of starter drivers. My expectations of what they think they are just unrelated. So they went to the place of, I don't want to learn to drive as a safe spot for not having to deal with the concept of dad disapproving of me. That's my theory. Maybe I'm a bad mind reader too. It's all entirely possible. So eventually my eldest learned to drive because I wouldn't let her go take her favorite ballet lesson thing when she was 15 and 16, because I didn't want to keep driving back and forth. You learn to drive. It's like 2 miles through the neighborhood. You're not going to run in any freeway or anything. Just she learned to drive. The middle two just would not. I finally beat the eldest son now to drive, and it took him like 6 go-rounds at the DMV because he would just kind of get, I want to say panic, and then he would, because I wouldn't be in the car with him, and so he wouldn't behave or whatever. He finally, it's like repetition, just got to the point where he was bored of being scared of driving to the driving instructor, a driving tester, and he just drove. And he's a fine driver. Done. And my youngest has a real excuse. He has every 7 years or so, he gets a grand mal epileptic seizure, and that's a hard no on driving. So it's been well treated now, and there comes a time when they will say, if you have so many years with no seizure, we'll let you drive. And the medicine he's on is known to sort of permanently reduce the odds of having a seizure. Like it does immediately also stop them while you're taking it, but even when you stop, the odds of them coming around are reduced sort of indefinitely as you get older. So he will probably reach a point where he's legal to even attempt, and maybe we'll get there. And my youngest daughter was, in the zone of panicking with me in the car. And so she wouldn't actually keep her head cool while driving, even casually, down the local neighborhood streets. She would be in an ever increasing panic mode until it was like no good. So.
Yeah, we understand our brains less than we understand our software systems.
For sure. For sure.
So anyhow, youngest son going to college, actually so the dorm room's open for summer classes, and everyone's had their shots, and COVID. So
nice.
But he's actually getting out of the house. You're going to be. See if he boomerangs back, but maybe. I think my oldest and my youngest, I think, are in the zone of they actually want to like get done, get out, not be part of dad. So oldest is gone, youngest might go. He's headed the right way.
So after C2, no one will build C3?
Yeah, exactly. Who knows? The AA's internal rewrites look a lot like a C3-ish thing. There's a theory that says make a portable, JITable thing. Like C2 was owned by Sun, then Oracle, and then it got open sourced, but it was never well designed to be a standalone jet. And there's a bunch of efforts floating around for standalone jets, and one of them is obviously use LLVM. Okay, LLVM sucks as a standalone jet, and I've had a bunch of people that I've worked with on using LLVM as their standalone jet, and it sucks. It's like horrifically slow, just horrifically slow for a jet. And the code quality is kind of meh because the jets all rely on profiling, which LLVM doesn't get, because you have to have a runtime that collects the profile data to feed to LLVM, which in theory you can do, but it's a big pile of work, and LLVM's not actually well geared for taking it that way. And you still have to do a runtime, so you saved the code gen, but you got kind of meh code gen anyhow, and you could.
What's the option? I mean,
Yeah, it's an option. People are doing it. I can't.
No, I'm saying, what's the alternative? You don't want to be.
Oh, there isn't. Yeah, no, there's right. And then I've seen various other bad ones. There's couple other JITs floating around. I don't know how well they stack up. I've only seen LLVM be used in a situation where it turns out to be pretty horrific. This is Julia doing large, complicated database things, and as a JIT for doing both development and for doing query optimization, it's kind of horrific for being so bulky and slow. I think are you doing LLVM too, Cameron?
That's our plan.
Your go-to. Just be warned, compilation times are unhappy, which turns into pre-compile is okay. JIT compile kind of starts to bite.
You find it's the compilation, not the link? Because I've heard a few stories of people that are like, why is the linking taking like 2 seconds?
Right. So the compilation was not fabulous, and then linking is not LLVM. And that depends on who's doing what for linking. So the guys I talked to ran it through another step that they had. This is a Julia team. They had dorked a linker in, and they did a classical bad job of a classical linker, which meant that every individually JITted piece of code went through a handle to get to the next piece of code, an indirect job. So if this got JITted and that got JITted and they were JITted in separate compilation units, then the cost was a full register indirect, a load from memory jump indirect, which blows out your B2B buffers.
Instead of a rewrite.
Instead of a code
func.
Instead of patching. Yes. So LLVM doesn't produce, near as I can tell, the necessary information to do convenient patching. So in the land of hotspot, of course, the JITs produce calls from one to another, and they mark those spots, patch me, and then you have a little self-modifying patch code that points one to the next. And now the direct call is a static x86 perfect 1/2 clock cycle call.
The second time.
The first time you bounce through and miss. Yes. And you patch it once, and then every other time is 1 clock cycle. And the LLVM strategy is every time through is 30 clock cycles. And also you rely on the branch target buffer, which you now blow out because you have too many of them. So all other branch target buffer jumps all suffer 30 clocks as well. Your branch target buffer basically gets blown out and it doesn't help you anymore. I'd love to profile that one.
So sorry, go ahead, Arthur.
I was going to say that you can do patching, and we do patching, but an interesting observation with, so in our system, having an explicit resolve for indirect calls or having an inline cache call doesn't have a difference in performance.
You got something going on then.
I think it's because we are much more aggressive in terms of profile-guided devirtualization and emitting switches for larger amount of predicted types.
You have profiles. The Julia folks have no profile data to speak of. So they emit a lower quality code, and they emit a lot of calls that with profiles you would have devirtualized.
Yeah, but I'm even comparing with C2. So I didn't measure, but like there is this kind of knowledge that, okay, ICCs are good for performance instead of doing explicit lookup every time. But then in our system, we implemented ICCs in a similar manner as C2 does. But then when we measured it, it doesn't show noticeable improvement. And I think it's because we are more aggressive with other ways to speed up indirect calls.
Oh, okay. Oh, that's interesting. Yeah, if you've already profiled and know the high order bit of what the call target is going to be, and you inline that directly because that's what your profiling hints at you should do, you don't take the inline cache call.
Yeah, I assume what happens is when we have an indirect call with resolve for ICC, it is a rare case of a truly megamorphic call which alternates between different types. And in this case, having ICC, like, it doesn't make much sense because it alternates between types.
Right. Yeah. Yeah. So inline caches help if you don't know the target, but it turns out to be monomorphic. If you already profiled and know the target and you jam in the easy one-off target what remains is megamorphic, and then you're going to do a jump in direct anyhow. You know, inline caches, the C2 inline caches fall back to a megamorphic call as soon as you have more than 2 targets.
How does that interact with something like ASLR, where every time you load the binary, all your compilation units are going to get sort of randomly sprayed around?
Well, moving the compilation unit means the target of the call moves to a different location, but the type that dictates the call is correct or not does not change. That one's different every time you boot up anyhow.
Right, but don't you need to wait to do your patching until you know where it's going?
Yeah. You all, well, that's the whole point of how these patching things work. The JIT lays code out in different places too, right? Because he does a malloc basically, and it lands, God knows, according to the schedule. So every time you rerun this large complicated program, all that JITted code all landed in a different location anyhow. So the branch targets for the calls are all done lazily.
Yeah, that's only really a problem for ahead of time compile.
Right.
If you're JITting it, then you don't know where anything's going anyway, ever.
And you're patching. It's basically in a linker step, you patch all those things at the link time. In the JIT, you're going to patch them, you're going to pay the patch cost anyhow, but you're going to do it incrementally as you discover targets, instead of doing it all at once during link time. But it's the same piece of work has to be done in the end. The one trick for the jitter is you have to have your patches now be multi-thread racing safe, which is once you've sorted it out once, it's not expensive. It's not that hard. Cole says, yeah, well, here's your man, Cole. It's Arthur's right there.
So there you go. They're using
this is the dude. Ask your question.
The JVM somehow.
Oh yeah, it's totally doable. There is this problem with compile time. Yeah, and as I said here before, like you get estimated to be an order of magnitude slower than C2. That's a rough estimate. Like if you're fine with that, well, it's like with some amount of work. For example, profile. Because we do it within hotspot, we collect profile using hotspot machinery, and then we just feed this profile into LLVM. That solves that aspect. So
what Julia does not do, and that
all of these things.
But isn't that kind of Azul's whole thing? Is what we care about is really happy steady state performance, and if it takes us longer to get there, fine.
Well, it just happens that most of our customers, they are running long living applications on beefy server machines. So in this case, we can afford much slower compilation because
you wouldn't want to run Azul for applets in the browser.
I don't know about you guys, but I'm really tired about slow compilers. I much rather much rather have a speedy compiler that be able to do a fewer things, but much faster. But instead of waiting, just one change and then waiting. Incremental compilation still doesn't help, I believe, because if you change too many things and it has to recompile all of them, and it's just my rant on slow compilers, not any one particular.
Yeah, I was a little curious of that with Sun's history. Why did they end up with Java C and not have the JVM just read Java code?
Oh.
In the way that like JavaScript, the thing that uses your distribution is the code, and you just compile it every time, and that makes iteration easier.
Those concepts weren't around. You had to have a Java C as a high-level language compiler. It wasn't super fast. It was a classic high-level language compiler.
Well, they were around. You had BASIC, and it was every bit as wonderful as it sounds.
And the high-level compiler, instead of spitting out machine code now, is spitting out bytecodes to be portable, because the theory was it would be easy to write a backend that read bytecodes and executed them as an interpreter, so you could get a portable code faster. Performance, by going down the route of an optimizing JIT, came along later. The concepts were in the air, anamorphic, and the Smalltalk self team were doing stuff there. People knew you could JIT code, but they hadn't, anything beyond template JITting hadn't actually appeared in any sort of production use case, hardly even any academic use case. And so when I sat down to go do basically my thesis for doing a compiler, you know, I got huge amount of pushback from every compiler engineer on the planet. Here I was, a young grad student doing compilers, and every academic and every compiler engineer I ever talked to said, no, you can't do it. Optimizing compilers are slow.
I have one question. Did you have deeply convinced that this will work?
Yeah, I knew it would. I was deeply convinced it would work. At my thesis, in my thesis work, I basically did a fast optimizer, and my advisor said, I can't sign off on a fast optimizer. So I moved my thesis around doing a piece of math. The appendix is as big as the whole thesis and has how to do a fast optimizer.
Appendix, by the way, this is what my thesis should have been.
Exactly. It really was. And then, you know, my thesis got picked up by Urs Heutzel, who's now uppity up at Google, while he was at Sun, and said, hey, this sounds like the right thing. Come do this at Sun and make Java go fast.
Yeah, but as I said, so much people you got pushback from so much people. Did you at a moment?
Every other person on the planet gave me.
Did you have a doubt in one moment that this will work?
No.
Yeah.
But that's been my case all my life. I have this strong intuition backed up now by 40 years of my intuition being right. My intuition says, fuck it works. I just haven't figured out how to make it go yet, but I can get there.
And be Bayesian about it. Start with randomized beliefs and correct them as they make bad predictions. You can't make a fast compiler. You don't need to update belief.
But you will have to have some core value, core idea that stays almost pretty much the same.
Implementations don't necessarily go in a straightforward line. Like C2, I knew I could read bytecodes. They were too simple, and I could spit out SSA form directly. So I went from bytecode to SSA form. I knew I could do code generation in SSA form because I was certain I could do it at grad school, and I did it in the sort of trivial language setup I had at grad school. That was there. When it came time to various other things like profiles getting fed back in, that seemed plausible. There's nothing impossible about it. How much it helped was not obvious. When I picked the 10,000 number for the number of trip counts before compiling, that was a shot in the dark. That turned out to be a good guess. When I did the register pairs for x86 doing long math, that turned out to be a disaster. The original long math was the IR understood a pair of ints with a carry, which sucked to make that all work because you had to have a carry flag, which you had to register allocate, and you can't have two instances of the carry flag alive at the same time, or you'd have to move the carry flag to a spillable register and back, and what a pain in the neck. Went on and on and on. Turned out most people using long math was crypto doing big integer. As soon as you do crypto with big integer, all your maths are basically high half, low half, shift left, shift right, add this, add that on each of the halves with carries. And individually allocating on your 7 x86 registers, the 32-bit halves worked out great. And you just had to carry between them occasionally. As soon as you went to register pairs and said, oh, the compiler will just treat them as a full 64-bit long because a 64-bit Spark was coming out. It was going to have 32 64 registers on Spark. Same implementation for x86, 64-bit registers. Well, I had to have the register pairs. You have 3, but you spilled like a magnet, and you spilled on big integer math for crypto. So all your crypto applications all sucked suddenly. You took a giant step backwards. Crypto's all your web pages, your web servers on x86s all went backwards. So we unwound that one when we realized that was a mistake. And kept pairs up until x86 64 was the common, and people didn't do the 32 anymore. So there were definitely mistakes made, but the high level concept of I can JIT code, actually I was doing that in high school.
Do you get did you get a motivation to prove all the people that you said that can be done, to prove them wrong?
There's definitely, I mean, there's references in my thesis to exactly that.
Yeah, do you say just hold my beer? Wait a little bit. Hold my beer.
You know, right. You know, I wasn't that much of an outgoing person. Like, you know, I'm totally willing to play poker with you while I'm holding 5 aces, right? So there's no point in me picking a fight unless I've already got the win in my back pocket, right? So there's definitely cases where I would go in after it had it running and say, and da 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 da, and say, no, you can't do that because, and I'm like, I'm doing it right now. And they're like, no, you can't do that. Look in front of you. I'm doing this, and they wouldn't look.
Yeah, that's a kind of strong argument. Yeah.
It happened to me all the time. So now you come and ask, hey, do you have these strong feelings? What I've learned from all that was I have to trust myself, because other people will come and tell me, no, you can't do that, or you can, or I don't know, I don't believe, whatever, and they're just don't know, and they wouldn't even look. You know, some people would look, and then you start to change the world. A lot of folks wouldn't even look. I'm doing this. No, you're not. I'm doing it in front of you. No, you're not.
Dunning-Kruger is strong even with educated people.
Oh my God.
That was a joke in a bunch of my computer science classes. Was in computer science, there are some impossible things that we do anyway, and some things we know that are possible, but we can't do.
Yeah.
And it's like, does caching work? In the general case, on the average program, if you take like the entire space of all possible programs, caching is worthless because every program it speeds up slows down some other program.
Right.
Except that actually, no one cares that on the arbitrary space of programming, caching isn't possible. On the set of programs we actually write, it works great.
Yep.
It works first for me.
Yep. At every layer. You know, hardware guys got there first. But caching works at every layer. Yep.
Moesha.
What's Moesha?
That's the acronym that they use in hardware for caching.
Okay.
I forget what it stands for.
Oh, you're not talking about cache coherency protocols.
Yeah.
Oh, yeah. Yeah, I give talks.
There's 50 different acronyms that are semi-pronounceable.
Well, it's because they have 50 different caching styles. That's one of the talks I do on why double check locking doesn't work. Is I start with a cache coherency protocol that people can understand, and then I demonstrate that your hardware does not work the way you think it does. It produces a great illusion, and exactly double check locking is when you peek through the illusion.
To what extent, when you are thinking about how you want to lay out your language, are you thinking about the way you want to lay out your standard library and your like best practices? So like Python lets you import anywhere at any time, which in theory would cause a huge mess and you would keep falling back into re-optimizing things. Okay. But in practice, everyone puts the imports at the top of the file. So you pretty much discover all of the code before you call main.
Okay,
and
you asked 3 different questions with 3 different answers. So best practices, I have a very easy answer. I predate all best practices. I have seen everyone on the planet decide they have this best practice and that and some other thing. And then 10 years later, totally reversed left and right and up and down, back and forth. I have my current practices. I'll tell you what they are if you're excited to learn. And if you're not, you're not. And, you know, I hear other people say, hey, and best practices are this or that. And sometimes I agree. And sometimes I think that's a bunch of hogwash. And you're just driving yourself down a hole that I don't want to dig you out of. And I see plenty of people who've done that. And occasionally I get called in to rescue them, to go dig them out of the hole they dug themselves into. And, you know, fine. So best practices are full of shit as far as I'm concerned. Right now, like getters and setters in Java, best practices, full of shit. I do not use getters and setters. And I have a long rant on Quora where I say why I don't, and I have strong reasons why I believe they're full of shit. And, you know, after that, we can go to town now or not. So best practices, boom, done. So libraries, you know, you have to have them. And now you have to have an easy way to get at them and whatever. And so I'm thinking about how I'm going to structure getting at library code and the like. And I don't have a solid answer. The easy one I have for the built-in things that you would get from a library that every program would naturally import, like in Java, system.out.println. Well, you get system as a library by default. You didn't ask for it, but it's a library, and it got pound imported for you automatically. Okay, so I'll have the same thing. And for me, that'll just be, I'll have a local variable called sys, which is a structure. It has a bunch of fields, such as print, file read, file write, whatever. And those will all be local variables that'll turn into functions that do the necessary things that you expect out of a sys library, and another one for, you know, maybe collections or lang, and another one for math, and Okay, so there's some default libraries floating around. Now, if you want to import other things, you get into a module syntax. And what's a module look like? And I've had some thinking on that, and I'm staring at, I want to say ML. One of these guys has got very strong module notion.
I would almost be tempted to put the import inside your sys module. Sys.import, it knows how to find it, whether it's on a cloud or a file system or an embedded whatever.
No, there's a different, there's import from the language semantic. There's where do you get it from? I do a lot of systems coding. I don't want to have my library change, so I don't want to grab versionitis changes without explicitly asking for them. Do the versions go into the code, or they go into your make utility round or whatever? That's an interesting question. The other thing is I want it to be able to work while my Wi-Fi sucks, because I routinely find myself in places where I have either no Wi-Fi or my Wi-Fi is extremely slow, but present and good enough for email. So as soon as I have to go to maven.central and go ask, is this version equal to the one on Maven? It's death by bit, right? If I had no Wi-Fi, the lookup for the Maven guy would fail immediately and say, just live with what you got. But I have a Wi-Fi, it just gets 1 byte a second because I'm flying on a fucking plane over the Atlantic. And so, it'd take 10 minutes to say it's the same, but it won't go instantly to a no. It has to check the interwebs. And so that's a hard fail for me. And so there's definitely a thing here where I want to say, you won't go check the interwebs unless you're asking for a versionitis check and maybe a versionitis update, because I'm ready to suck on a version update, right? Where I've done a lot of JavaScript development where by default you got new versions whenever they rolled out with hardly doing anything at all, and that meant that you went to interwebs all the time, and that meant as soon as your Wi-Fi sucked, your development ground to a halt. So you had to turn off your Wi-Fi and you could potentially do development again. And that wasn't JavaScript per se. That was the development infrastructure that floated around, Node.js and the like, that floated around, and all the packaging that went with it. So there's an interesting packaging question that I haven't sorted my head on. I'm kind of thinking I am going to have some sort of module thing. Given my current state of my syntax, it's probably going to be sys.module, and then I don't have to add a syntax for modules directly, and it's just going to be a function which, given a string, does a module lookup in the local file system hierarchy. And yeah, here's my getters and setters rant.
Although I disagree with you, but excellent. I disagree with you because I learned something from this brilliant guy who wrote this compiler years ago. Because Hotspot
should inline
outside of the syntax nonsense of getters and setters, which is absolute shit.
I'm outside totally of that on the syntax. Also, it turns out that you will fail to inline periodically where you think you should.
Yeah, but then I'll go find someone who wrote C2 and see if they can help me.
Yeah, so I'm out of that game. But my next game, I am totally going to have a way for you to demand inlining. And then I'll just force the inline as it blows out your compile time. Fine.
Or another alternative, make a smarter inliner.
I'm sorry?
Another alternative is to have a compiler with smarter inliner.
I will bet you I can make LLVM fail to inline a getter and a setter as well. I totally 100% guarantee it.
Like, yeah, okay, of course.
It's very strong. So there's some ways you could do it. So I'll start by giving you something that you would like to inline and recursively like to inline, and I'll go a million deep. And I'll ask LLVM to run out of memory and die, or inline a million deep, right? And at some point,
it's all heuristics. Like, we cannot find an optimal solution. So you can find an example which will break an heuristic. But...
So the heuristics on Hotspot's pretty good. It's hard to break it, except every now and then I get it broken. So it happens. So you could argue it could be tuned some more. And like I said, I'm out of Sun, so I can't make those tunings anymore. And I would change
open source. You can always do a pull request.
Oh, I'm not touching them. Oh my God. Maybe OpenJDK, whatever.
Yeah, that's what I meant.
Fine. Okay. So ranting aside, the syntax issues suck. That's the whole point of that problem. I can't see through the open close paren of the forced function call to decide what the cost model is. So the bigger fail that I'm ranting about there is, what is the cost model of this thing? Well, if it's a local field access, the cost model is one clock in and out of my caches, and no side effects are not obvious, and racing according to whatever I've decided I've got with coherency going on or not. With the parens, I don't fucking know. I have to go look. When I look once, it's okay. Look 10 times, it kind of fills my head up with shit I'm looking at. Hey, this one was safe, this one was not. If I got a million of them and they're everywhere, I can't look at them all. And then suddenly I don't know.
So you don't like the parens?
I don't like the enforced unknown semantics.
And that's my favorite part, because that is exactly what polymorphism is, right?
Exactly.
Because sometimes I say, give me X, and I want a field, and I want to pay for getting a field. And sometimes when I say get X, I want it to freaking calculate for me, because I'm looking at it from a different angle, and I'm using a different point, and I want a different X and a different Y.
Right, and that's the difference I make in that rant. There is an ABI. If the ABI turns into a field load, that's great. If I need a field load because I need to know performance or I need to know multi-threaded semantics, I need a field load, not a getter and a setter. So there is an API. If the API is busily saying, I'll hand you the rotational codomain of the SLID visualization transformation matrix, and it happens to be an X and a Y, unless you've applied a bunch of transforms and then it's some horrible pile of math, that's a fine API and I can live with that. And I'm okay, right? If I say I'm trying to write—
But the point of an API is that it's unbound from the implementation. So
if I'm trying to write an API that says, I'm going to write a high performance multi-threaded cache to back my database. So my data, I don't go to my database, and all my threads, my giant busy web server, are going to tackle this one shared piece of memory. I need to have shared memory that the hardware has directly. And for that, I need a field. And so that's one of the cases where I need a field. The other case is the usual one for big data, where I know I'm going to run a big—
I'm with Arthur. We just need a better inliner.
No, you need a cost model that you can rely on, right? When I need a low cost for the terabyte data set I'm going to stream through, I need a cost model, because getting that wrong slows me down by orders of magnitude. And I totally have these examples in common everyday shit. Okay, so there's a cost model guarantee. Then there's a semantic guarantee for multi-threaded shared memory. Given those two different things, right now I'm overloading them on don't do a getter, don't do a setter. Then there's an API which says, hey, be efficient, typically be averagely good, be whatever, blah, 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 but give me the semantics of the size of this collection, which is often a field load unless it's a concurrent collection, and then the question is questionable. Can't ask the question of how big is your concurrent collection reliably.
Yeah, I think there are two aspects here. But the first one is, well, it's a boundary for an optimizer, and this can be solved by smarter inlining. But I think another point you are making here, that it's a boundary for a developer, and when you write code, you don't see what it means. And here, an inliner will not help. You need a smarter inliner in your head in this case.
Yes, but also the case where smarter inlining for performance, I need, as a developer, the guarantee that it inlines. And as soon as I have a syntactic notion that I guarantee that it inlined, I don't need a getter. I've just inlined by hand. And that's the no getter. I mean, that is a way to achieve the semantic of, it's a hard guarantee of inlining.
But the biggest challenge with that, like, I totally get what you're saying, and I would trust you to do it. I just wouldn't trust anyone else in the universe to do it. And any team larger than one person is going to fail with that because it's not composable. That's the challenge.
I would draw that line slightly differently. I think that I need to really understand the performance characteristics is absolutely true about the most important code in the world.
Are you saying I
absolutely
exaggerated?
True about probably where most of the cycles in the world go. It is certainly not true about most of the lines of code in the world.
Yes.
Because if you have a 10 million line code base, chances are you've got 100,000 super important, super performance critical. Your business dies if this code has different performance characteristics than you think. And then you've got 9.9 million lines of code that you care a lot less about because it's handling some special case that only happens during the second 2 o'clock in the morning on leap day.
Not even that. It can be your normal case of doing it like an Amazon web server, but you have high performance pieces buried in the average every day. I just want to get some shit from this database and that database and look up your name and do an SSH and SSL, There's a lot of shit going on that you're going to do all the time. It's really important, but it's important that it's functional and it's fast enough. And then there's shit going on where it fucking got to be fast or you die. And that's the one where I want to have a cost model I can rely on. And a smarter inline doesn't give me a cost model. It tells me that I less often fall over the failed inline.
So is it only in that code that you want the getters and setters to go away? You're fine with it in the like miles of low quality code?
Yeah, the usual story for the miles of low quality code is the getters and setters just obfuscate the understanding. That I typically, that if there's an ABI to be had, and the ABI says, I'm returning you some complicated thing that is often cached in a register and shows up in this field, then, you know, a getter is fine because it's not really a getter, it's an ABI that gives me the size of a collection, for instance, right? And I'm getting the size of a collection. Okay, there's a parens after the size of a collection that tells me sometimes getting the size of a collection is expensive, sometimes it's cheap, sometimes it's complicated, I don't care. I get the size of the collection. It's not a performance issue. And I understand the size tells me it's a no side effect, common, whatever. It tells me the semantics, right? If I have some giant wad of code of somebody else's I'm trying to understand and there's a parens, I don't know the semantics. So now I have a semantic load to go discover what this function is. Oh, it's a fucking getter. Is it part of an API that I should understand the API instead? Or is it just a getter for no reason? Well, if it's a getter for no reason, I would fucking unwind it so that next time I go look at this giant wad of code that I don't know what it does, the semantics are obvious, right?
Well, but this is just one specific case of a general thing that, okay, there are abstractions which improve composability, improve scalability, but they have a cost. And there is a cost in understanding, and that they hide things. And
that goes to saying you have an ABI. You're composing, you're putting a getter down because you want to change the implementation from loading a field to doing something else later. That's the composability.
Yeah, and I think on this call, many of us have a bias towards high performance code because that's what we are looking into. But I agree that the vast majority of the code, like it's not that important. And it's better to have this flexibility, probably.
All right, so I'll claim that most of the code I look at, while it's not important in terms of performance, it is also the case that the ABI never got a moment's thought. That somebody slapped it together and moved on. And the ABI isn't really an ABI at all. It's just what it happened to be after they got on slapped together to go solve the next problem, the next, and then they never ever have time to go back and do code cleanup. So most of the time when I see a getter and a setter, there's no ABI around it. There's no reason that you would change this. It's just the implementation because the guy's best practices was fucking put a pair of parens around and move on. And then, oh, sorry, somebody bailed. And then, you know, it was left that way. And 5 years later, I'm looking back and why is this a getter and a setter? It's some final field that I'm just going to read and get some, you know, whatever out of it. It's never changing unless I put an ABI around and we agree there's an ABI that's not actually changing. And as soon as you have a getter and a setter, you don't have an invariant field anyhow. It can be set.
Well, I think we can all agree that having to write a getter and a setter is ridiculous.
Thank you.
Like that's certainly not the.
I can't tell if you're being sarcastic or not because you.
Oh no! Like it was cute in '96, but it looks like shit now. Like it's.
Fine.
Yeah, I mean. It's just awful. But the bigger point I was making where I disagree with you is that, like, if you think about a field, it's just a virtual concept. And as a virtual concept, I know you don't think of it that way. You think of it as a chunk of memory. I don't. I think
it's a chunk of memory. It's a performance model. It's cost of various kinds.
Yeah, but Hotspot taught me that I don't need that.
I do, and I do all the shit with Hotspot. I totally know I need it. Fine.
Yorick, were you going to say something?
I was going to disagree with the notion that getters and setters are useless, like quite heavily even. I will say that the Java syntax leaves a lot to be desired, as in there is none.
Well, it was parens.
I think, put it this way.
Call.
in Ruby, you can have a method containing actual equals. So you can do something like def number equals. And then the syntax for calling that is something dot number space equals. In other words, it looks like you're assigning a field, but it's actually a method call.
Yeah, I think that's even worse because I don't understand the semantics. There's a way to make that work.
Right. And I think the key there is to not make fields and method calls basically look the same.
Yeah.
That is, I like in Rust, for example, if you have if a struct has a public field and you have a method with the same name, it gets confused when you refer to that field without the parentheses. Or I believe you might straight up error, right? I don't fully remember. Because it's like, which one do you want? Like, it can be both. And I think that's one where you need a different syntax for one of the two. But I think the concept of getters and setters, regardless of the syntax, in general makes perfect sense. Like I've had a few too many cases, at least in my VM, where I used a field and I then wanted to refactor it to a method because instead of it being a field, it now has to read from some sub piece of data, whatever.
I do that transition all the time.
Do locking. And it's like, well, shit, I used this field in like 80 different places.
Right.
And there's no there's no automated way of effect like, hey, when you find this field, replace it with this call. So now.
Is. Or I do it all the time in an automated way. I want to say IntelliJ certainly will do it, but Emacs will do it.
Yeah, the scary thing is not I use this field in 80 different places. It's I published an earlier version of this library that someone out in the world who compiled 10 years ago is making assumptions about, and now they can't link against my new version of the thing.
That's a different problem, and that's a module. When I go to take code that's not under active development, so it's a release, I'm going to define an ABI and I'm going to put thought into it. And if I fail to put thought into it, then I get a stuck situation just what you described. But if I put thought into it, then there's an ABI and I close up all those open corners as part of putting the thought into it. What I want to support for later down the road, right? That's a case of I released into the wild a poor ABI or API, and now I'm stuck with a poor API, which I agree is a problem, but the fix isn't to change the language. The fix is to not release poor APIs.
No, and I was going to say there, like it's not just like, hey, I use this field in like 80 places. Yeah, sometimes you can, quite easily find and replace it with something else. Like if it's a simple case, instead of this field, we now use a method, and it has a, like we didn't pass any complex arguments around or needed or whatever, easy. I will say that as with all things, there's no sort of black and white answer. It's not like, oh, getters and setters are bad or they are perfect. It seems people do interpret that way. They're like, oh, we have getters and setters, so you must always use getters and setters. Instead of this more middle ground where I'm usually leaning towards like, do you need this in the first place? Like, regardless of whether it's a field or a method, do you need this? Because I'm pretty sure a lot of times the answer is basically no.
Yeah.
And after it kind of depends. Like in my language, the syntax simply disallows direct field access. And it's not just because I like getters and setters, a bunch of other reasons. And so you have to create a method for it.
So we over-engineer our code to make it more composable?
Oh, a lot of times, yeah. Like I actually, last week, I spent working on some code that managed to be both over-engineered and under-engineered at the same time. Yeah.
That's quite a feat.
You're not more composable by putting down getters and setters directly. All that means is that I have to have an extra syntax to set fields and get fields, but there's a state under there. And as soon as I want to change the implementation...
I disagree. I don't think there's any extra syntax.
State manipulation. I'm sorry?
Why would there be any extra syntax?
The other version of the no extra syntax is the one I run into where I can't tell you if I'm looking at a function call or not, and now I have no cost model. Right, there's the by default there's a getter and a setter, and you don't have to name the parens. They're just done that way. And now I don't know what my cost model is. Maybe I'm doing a field assignment. Maybe I'm doing an arbitrarily complicated function. Sometimes I don't care. Sometimes I care a lot. But I have no way to come out and say, and oh, please, must be a field that I'm touching here because otherwise my cost model is blown. And that's why I don't like the no syntax. Alternative shortcut syntax, whatever that is, says there's a function call, but we're really backing it by a standard by default getter and setter, except it can be overridden. Gets me a little closer to a cost model I believe in, except I have to know if you bother to override it or not.
Yeah, that's basically the model that we have. The compiler determines whether or not it requires a field, based on whether something can be stored in it. If it requires a field, it has one, and it pretends that it creates a getter and setter for you, but of course there is none.
You have a different thing here. See, I claim that when I'm talking getters and setters, I'm doing field and state management, which has memory, model, semantics, and cross-coherency. And here you have just a function call, returns an interesting value, and the fact that you can or cannot or did not back it by a field is unrelated. You just got a function call, returns me a value that's exciting. Somewhere in the universe, it maybe has a backing state and maybe it does not.
And if I say int x, though, I get the same thing minus the overridden get. And I'm also guaranteed to get a field because it needs it.
Okay, I don't understand how that particular get gives me the same thing as an int x that I can read, because I don't know
because from outside, the way you get the ID is you say ID. And that gives you the ID. And the way you get X is you say X.
What is the ID mean here? That's what I don't understand.
Well, let's say these are both on some object O, right? So I just say O.ID, or sorry, int n equals O.ID, right? Or int n2 equals O.x. Right?
Okay. And I don't understand what the get semantics are. It says tx $dot right ID assert. I don't know what that one is.
Oh, sorry. So that's just, so that nomenclature of dot get is just short of saying open curly int get open curly return blah blah blah. So that's just a method on the.
No, I get itself. That, but what's the method body doing?
Oh, there's another field called, another property called tx, which is a nullable transaction. So if it's not null, it returns the right ID, otherwise it asserts. Panics.
Okay, and what's right ID?
An integer.
Where did it come from? Who said it?
In this case, it was set in the constructor. This is a transaction context.
Okay. So when I do unique identifiers for objects, which I do all the time, I have a bunch of things I want out of that, including the property that it's unique. Typically, I want that it's small because I'm going to use it in various kinds of testing of things. And it's a field that is set on construction time as a final field. Being a final field, there are no setters. There is only a create with its unique ID. And then because there are no setters, the get can only ever get the field.
Yeah.
So the get just gives the
So
field.
we have immutability in the type system. So if it's known to be immutable, it could still have a setter, but the setter can't succeed. Not not after the object becomes immutable.
Type error you on your setter and claim it's immutable. And in this particular case, for this context, what I'm understanding what you do, I would set it in the constructor.
So we actually can, if we can prove that at runtime it will be immutable, we do exactly that. Yeah.
Yeah. Okay. Yeah. All right. Well, in my case, I'm claiming I'm going to tell the compiler it's immutable. Although in AA, I would tell the compiler because I would use immutable assignment. Use a final assignment in the constructor, usually of a small dense integer that's hidden as a counter, and it just incrementally bumps up, but that one's hidden. And the constructor can see it, but no one else.
So Yorick, what's the @ sign? Is that a field?
Yeah, that's the syntax for fields. I took that from Ruby. Okay. It's originally because I called them attributes, so the @ sign. I've since, at least in my VM refactoring and everything, started to just call them fields because attributes is a bit of a overloaded term or loaded term. Not sure what the right word is. Like Python uses attributes for fields. In Java, they're like the things you can slap in front of a function, similar. And then Python has what they call decorators, but that actually are attributes basically. every language calls them something different, whereas field, I think, is universally understood as.
Yeah, Python just wants to call them attributes instead of fields to warn people that at any time accessing one could be a function call that takes arbitrary actions.
Yeah, right. That's what I'm looking for.
If I say A.B, I may have just fired the missiles.
Right. That's what I'm looking for in a syntax to tell me I have a function call going on.
Yeah, so I approach it like a lot of languages have this sort of problem where there's ambiguity, like fields and methods look the same apart from the parentheses. Part of this is decide like just give them an extra symbol that's your field, and then you don't have that problem. It could have been $, it could have been something else. I picked @ because I'm used to Ruby.
Right, that's fine. That's not the issue. The issue for me is as soon as you have a getter and a setter, why did you bother with either? Because in all cases, I'm just going to have direct ability to manipulate the state.
Right. Yeah. So in this case, though, the fields aren't public. So in a language where you have public fields, then yeah, I would argue getter and setter that just
what's the
writes
difference
the field
between public getter and setter with a private field versus a public field? What's the difference?
Yeah, but it's basically the same.
Okay, that's my point. They're the same. So why'd you bother?
Right. If I have point, I might have my public getter and setter be XY and my internal representation be polar.
Right. So
then you don't have, oh, I see. You have a setter and you have you're doing a function call to go manipulate the state.
Right. I'm doing trig every time. When you set me, I turn it into polar, and when you get me, I take it back and turn it back into.
You have a true bijection between an internal representation and an external representation. You have a true bijection. As soon as you claim that I do floating point computer math and it's not a true bijection, I'll have ULP errors as I jam in values and pull them back out. So if I jam in, 1 and a 2 for my X and my Y, and you polar it and I grab them back out, I won't get 1 and a 2 back out. I'll get the plus or minus sine, cosine, ULP errors. Right, and so that's an interesting fail property. It says if I assign a value and then I read it, I don't get the same answer back. It is not the case that storing a value in X and then loading it out in your polar example will give me X again.
Right, I have turned data into function.
But
saying by default you should use getters and setters is saying you should prefer functions to data.
The semantics here are, I have a getter and a setter which I pretend I store as a state, right? And therefore there's an assumption that your argument is wrong, which is if I store a value and then I load it, I get what I stored. That is not the case in this example. The usual thing is if I store the person Yorick into the name field and later I pull Yorick out, I pull the name out, I get Yorick back. But if in
I would say that's not a fair assumption for any pair of setters and getters anywhere.
In any arbitrary functions, proving inversion is ludicrously difficult to impossible. So it's just not invertible typically. Whereas a field store and a get is entirely invertible down to the bit set level, right? The bits are identical, so nothing changed there. That's a key difference that I would have to claim that you should document the hell out of. My ABI is I take an X and Y and return an X and Y, but I do things under the hood with them, and I do not guarantee you what do we call the word, transitiveness or community or whatever. I don't give you some basic properties that you'd expect if I was using a field. And
I would say that like that makes perfect sense. I just think in sort of I'm generalizing here. I think in a lot of cases people just don't care. Like they don't necessarily.
If I throw points.
Put it this way, this might have just been my experience in the last 10 years. I've not seen a program where it had a setter called a set name, and I gave it the name, and then there's a function called get name, and it gives me back an address. I've not run into that code, at least where it wasn't broken straight up.
That's not what I'm saying here. I'm saying as an arbitrary, kind of notion of throw down getters and setters everywhere. In the case where, Aaron just pulled out, you would fail to be able to put points into a hash table and pull them back out. Because I would key on you putting 0.1 and 0.2 in, X and 1, Y is 2, throw the point in, and I go look again, and the key fails because 1 and 2 don't match 0.99999 and 1.99999, whatever, unless I make a hash function which doesn't do equality, but does approximation on delta. Fine. It gets complicated, and suddenly semantics are non-clear, and some easy use cases fail. Whereas the one where you're talking York, where the getters and setters don't do something obvious, are busted, or typically if they don't do something obvious, it's because they're busted. In my case, that's another argument that says, why did you have a getter and setter in the first place?
Right. That's where I was kind of going. Like you
just voted for me, so thank you.
Yes. So I think generally my point is like I generally like getters and setters when the process of setting the values is non-trivial. So when there's extra work that might be necessary.
Yeah,
so you have, say...
Right. I'm canonicalizing the person's name. I am doing capitalization issues. I disallow you to have like Elon Musk's child's name with Arthurfield.12 or whatever the fucking kid's name was going to be as a name and shit like that. You know, you do normal things for... Yeah, that's an API.
Right. And so for that, I think getters and setters are great. I do feel that when you expose fields
let me break out the difference here. I claim that's not a getter or a setter. That's an API call.
Oh, right.
The API says, I take a name, I validate it as correct, and I will return you the corrected name, or I do a correction statement on the name. I remove embedded spaces, and I've got my close curly SQL attack name, you know, whatever, little Johnny, Bobby drop tables. Whatever the XKCD on
the tables,
little Johnny drop tables.
Yeah, I do those things. Okay, that's not a getter and a setter. That's and I do semantic cleanup on the name to verify you're not trying to fuck me over.
But you're still stuck thinking about C structs. I mean, that's what it comes down to. And
that was going to be my second point.
It almost sounds to me like Cliff and Cameron are arguing the same underlying statement and just have inverted values from each other. Cliff is saying I should use a memory rather than two function calls because a memory gives me a much stronger API and much stronger guarantees.
So early
Cameron
on
is saying I should use two function calls rather than a memory because two function calls gives me a much weaker API and fewer guarantees that I'm going to have to keep those promises forever. And the difference here is that Cliff wants a stronger API if they can get that strength for free, and Cameron wants a weaker API if he can.
No, actually, what I want is an API,
so that he has more flexibility later. Is that fair?
So a field access is not an API.
It can be. That's a difference. Maybe we have that. Maybe it goes to the underlying difference. I totally have field accesses that are the API, and it's especially true in all my concurrency stuff. The field access is the API.
Yeah, well, the other thing I would say is that, you know, language kind of has to hang together as a whole. So the decisions you're making are making sense in a whole. And I couldn't take some of your decisions and have them fit with others. So, for example, we don't have concurrently mutable data.
Right.
We just eliminated that problem.
I understand. And I claim there's a large class of high performance computing for which that's not, that are commonly done. That's not a great answer to have it not available. Or you switch languages to C to write your giant concurrent hash table that you're backing your web server from, and you're not writing it in ecstasy because you can't. I can't write an OS in Java. God knows people tried.
I think what there would be for me, like if you have like an arbitrary class or struct, whatever you like to call it, I'm generally a fan of keeping fields private, mostly because those kind of types are generally more used for behavior and not just data. And with behavior, I want to have the freedom of saying, hey, you know, this is no longer a field.
API, and your behavior is hidden behind the API, which happens to include some fields, but that's the hidden behavior I don't have to tell you about. I have an API. Yeah.
And I think if you have like some sort of like data class or, you know, the traditional struct before you could attach methods to it, I think their public fields make total sense because at that point, the type is essentially a fancy tuple, just named fields instead of index-based.
And it has a cost model with
I generally agree, but it's a mutability that makes it really easy to do. So, for example, if your class that has no fields but has just properties that happen to have behind-the-scenes fields, if it's immutable, then the compiler is like, sure, why wouldn't I inline all these as direct memory accesses?
No, that's not the programmer's model. That's the performance that we kind of get on average, which I'm okay with. There's a programming model that says this struct has the behaviors of that I want, which would be its size is known to be reasonably small, or I can optimize the size because I have a billion of them. and they have to fit. And so there's a size question, there's a performance question, then there's immutable or not, which is sort of another orthogonal domain, because I totally have these billion things that some of them I have mutable things and they get mutated, but they have mutated concurrency. So the field becomes the API. And I can't express this in the model that Ecstasy is promoting. And I'm not saying you should or you shouldn't.
Totally hear. I totally hear you.
But there are codes that I think are exciting and used, and
yeah, I mean, one of our goals for the design was to be able to say, for example, I want an array of person, and then fill it with people, and only have a total of one allocation, right? So how do you do that? Right. I need the runtime to be able to make that decision based on
the size of the array if you want to do that with one allocation.
Yeah, sure.
Count peoples.
And so I have an array of 5 people, right? And the first one is a new person, the second one's a new person, the third one's a new person, the fourth one's a new person, the fifth one's a new person. How many allocations were there?
You could do it in one. You can do it in one in Java.
You could do it maybe in 0.
Only if you're going to recycle it, then it's all stack allocated.
Well, exactly. I mean, and who knows that? Who knows that best, right?
The issue here is if there's small set of things and I'm just don't care about performance, then I don't care how the implementation goes. And having a better abstraction layer is all great. As soon as I said I have a billion persons, I desperately need to know whether it's going to cost me 1 byte, 10 bytes, or 100 bytes to hold that person, because that tells me if it's going to run on a standard 8 gig Amazon T1 class, blah, 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 or if I have to go to a fat machine, or it just won't work. Right, it really quickly gets to it just won't work.
And it goes back to some of the early big data stuff that I saw, without naming names. The Pentium Pro 200 was faster than the Intel 800 megahertz, whatever, Pentium 3 or whatever Pentium 4, I can't remember. But the reason was it came down solely to the fact that this antique Pentium Pro 200 had the giant 256 kilobyte L3 cache. And that was enormous in the 90s, right?
Yeah, it was.
And because you could design the C code to put the big data in the cache, you would actually completely mop the floor with a 10-year-old newer,
10-year-old,
10 years newer CPU running at 4 or 5 times the gigahertz. I won't claim that I was
responsible for that, but I totally have been there. I mean, not directly, but pretty close. Yeah, totally. And all I'm saying now is I would like a language that have a cost model I can trust to go be able to make those design choices and have them be verified through.
And I totally get why you want that, and I totally trust you to make those decisions. It's just the other 99% of us that I don't trust.
That's the funny thing. I get people coming around that, okay, fine. It's like, it's easy, it's obvious. What the fuck? Why can't you get it? Well, most of you guys all can get it. But you're correct. I find people who don't. And now I'm like, why not? What happened here? And
that's one of the things that I found was two-sided. Languages like Python really hide the memory from you. It's hard to know when you have done what in a language like that. As a side effect, the people who spent their entire careers programming in that language, it's not obvious what's fast and what's slow because they can't see the hardware.
They don't have a cost model. And Java did the same thing.
Whereas like if you gave people a language where you could see the cost model and people could be like, oh, let me change this and change it back. And oh, did that get 10 times faster and then 10 times slower? You would start to internalize the cost model because you could.
Right. And Java took that away from compilation at least. And I understand the layers on all sides, so I can make Java go fast. And you meet a lot of people who exactly blow the cost model, like you're saying. And Python's a great example.
I mean, I have very little sense of the cost of calling a function. And that largely comes from the fact that I've spent my entire career in languages where when I call functions, it inlines them and makes that cost go away. And I cannot reason about the cost of a function call because I've lived in a world where, for the most part, function calls were free and I can't tell when they're not.
So they cost the body of the function and 1 clock, half a clock, basically free if you are making a static call. And if the call is something complicated, like a Java virtual call that's really virtual, and many other languages built on a JVM or not built on a JVM have a complicated calling model, then you pay the cost to do the lookup to get the call, which in the case of a Java virtual call gets beaten down to an indirect call, 30 clocks. How does that stack up to the cost of the body of the function? That depends on what else is going on and all that, right? So it's 1 clock or half a clock or 30 clocks or inline to 0, always plus the body of the function. Turns out you also get callee saves and stores and reloads if your things are a little bit complicated in the body. That goes away on the inlining only, but you pay the cost also. And those turn into half a dozen, 1 clock to a dozen clocks, according to the complexity of the body. It's an add-on cost that you get. That's one of the inlining benefits, is to get rid of the prologue, epilogue costs. And then after that, inlining gives you other things according to what the optimizer can go to town on. So, you know, your cost is 0. It's pretty close. It failed to inline. Now, if I have a virtual call on a hot loop where the hot loop is doing, you know, I have many megamorphic targets for the hot loop running over a billion things. Hey, let's talk about, you know, big data math machine where I do compression. I have to do decompression in the hot inner loop on every element I'm doing math on a billion or trillion elements. Well, that vcall costs me a shit ton, right? So if I'm doing a DAXB, SAXB, I'm going to do a multiply add. I got 1 to 2 clocks for the multiply add when it's pipelined and throughputed. I got 30 for the vcall. So 15 times my performance is tied up in the vcall. Once I do it a trillion times because I'm doing big data, that's all my time.
So how do we make it easier for developers to see that?
Yeah, well, exactly. And that's where I'm trying to sort out what to do here on how I express a cost model. And I like the notion of, for instance, single inheritance is a common way to code. It makes a lot of sense to me, but you can go to a point where you have a virtual call. And now how do I declare that I want it to be fast here? And for me, the current strategy I have, and I'm not tested, not used it, just throwing thinking out, is I'm going to say everything's easy by default, unless you ask for fast as a type over a lexical scope. So in this lexical scope, I want fast. And what does that mean? That means I will disallow as a compiler error everything that I can't prove has an obvious cost model. And then where I don't know what the cost model, where the compiler doesn't know what the cost model is, and he doesn't believe the user can see what the cost model is, he'll blow an error out. And the user has to one by one exclude or include things and say, I'm changing the code, or I'm acknowledging, and here I'm going to eat a vcall. I'm just going to eat the vcall and be done. The other one, of course, is allocation has a giant cost in these kind of scenarios, far beyond the bump pointer. The bump pointer is 1 clock, and you rarely run the bump pointer out. The memory you get is guaranteed never in your cache since the last GC cycle. So you're hard guaranteed a cache miss and bandwidth that comes with it. And then you run out of bandwidth, and that's your cost. So the fast, go fast syntax annotation, lexical scope annotation would say, no allocation is allowed in this inner loop, or none that is hidden behind an automatic auto boxing operation, or you can allow one, but you have to okay them individually as this one I accept, and otherwise I need to know, that especially marked, no hidden allocations. Same for no hidden vcalls. All calls are known to be inlineable.
So if I say no vcalls at some point,
yeah,
and I've got a running system and it's following this rule,
yeah,
and then I load a new class that would have turned that location into a vcall, what is the appropriate thing to do at that point? Do I throw an error that's like, you could not load this class because it would violate this assertion?
Class load error. Class load error. It's a class.
So the system keeps going. It just won't let you load that class.
Yeah. Class load error. This call causes this code to go virtual, and this code is known to be flagged as not allowed to go virtual.
Yeah. As another suggestion, you can have a code that prevents closure to capture variables. So they are. Yeah,
that's the Scala bug, but that would happen to me too. So same thing for fast.
Hard guarantee that you some syntactically you restrict the compiler to not capture anything. just to maybe convert this into a function pointer in C. I don't know exactly how it works, but yeah.
No, yeah, that can be done. This is the same game in the same way, and the sort of easy thing here is there'll be lots of these, and so I need a different token for them all, but this will be a separate namespace for this kind of thing, followed by groups of them that you would claim would be usefully grouped together, like the fast would exclude new allocations and virtual calls that are hidden, and the this, but there might be other places where I just want to know that you're not escaping the this pointer or closing over anything or whatever, because that turns into an allocation typically, and an object that gets hung around. What you thought was a function call actually carried an object with it, and so every time you make the function call, you make a new object, and so the cost of the function call becomes the cost of an allocation with the cost of the function call, and that would be one of these, no.
Have you considered an allocation on unwind?
I'm sorry, an allocation on one line?
On unwind. So stack allocate and then automatically lift on unwinding.
Yes, stack allocation is not heap allocation and has the right performance properties. So I would totally allow stack allocation as a thing that could happen.
But if you have to heap allocate and copy the whole objects off the heap at a return, you could end up with a return that is surprisingly expensive.
Yeah. Yeah, that's not, it's not.
Well, yeah, but you take profile information, and out of 10,000 runs, you see that 9,900 of them, it doesn't escape on the stack, meaning it may escape to a subframe, but it never escapes to a superframe, and it doesn't escape to a global, whatever your global is.
So I did the stack-based allocation hack at Azul long ago, came up with great numbers for what I could stack allocate in a big, busy web server. And the answer was the cost to failing is an issue if you fail often enough, right? So now when I say I want a semantic proof that it didn't fail, I'm not going to look at the profiles. I'm going to look at, I can prove that it will never fail. There's a different model that says I can get you to the 99% case and it's much faster, and I've got just generically goodness and light speed, but no proof that you had goodness. So if you're writing hard real time, or you want to get the 99.99% web server response code, you want to know that it didn't actually ever hit the fail mode. And so that's the proof that you didn't fail, right? And that's a semantic change to the code. And if I can't prove it, then I'm going to say, here, if you throw this exception, then you allocate an object on the exception throw path because I took a network timeout to the database, blah, 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 blah. Okay, now you have to decide, I'm going to be hard real time, or I'm going to be 99.9%. And maybe that's good enough, and you walk away. But if you're going to be hard real time, you're going to do something else. Hey, when I throw this exception, I'm actually going to pickle it into a small integer I've pre-allocated on the stack as an error code. I didn't actually do any allocation, and I just kept on going with whatever I needed to do. Knowing that this network call didn't come back or fail or whatever, fine. I mean, however you want to structure it, right? You're looking at a way, I'm looking at a way the compiler can give you a hint that you have a hard guarantee of the following performance facts, or you don't. And if you don't, now it's your problem, and the compiler gives you a hint. Here's your cost model. Fix it how you want to.
So one good question, how can we handle futures? Futures most certainly are located on the heap, so they do not know when the API call will return. If you do,
I suppose don't use futures as a bad answer.
No.
Can we have something in between the futures that are stack allocated somehow, and you periodically pull it to see what happens?
This goes straight to you're asking the optimizer, was he able to prove without a doubt that he could stack allocate this future? Because if he can, it's hardly a future. Semantically, you're thinking about it as a future. The implementation, fuck it. He pre-computes, he post-computes, you can't tell, you don't know. He gets the same answer. It's all stack allocated, and therefore it's fast, and your cache isn't fast. So that's another game where you ask the optimizer by putting a syntax annotation that said no allocation. Oh, I did a future, and the optimizer couldn't prove that the lifespan of the future, blah, blah, blah. He had to allocate on the heap. You got an allocation, death, right? Syntactic death. Don't write a future here. Or the optimizer could. So there's some classes of programs where you would start by saying, this fails and I have to write it in a simpler way. And later, as improvements come to I say optimizer, now it's typing. Later improvements come to typing, and more programs type than did before, and more expressible coding styles can be hard cost model guaranteed.
So this is pretty interesting, I believe, because most of the APIs, if you feel the need or feel pressure to change to the API to asynchronous, then now the signatures change. And most of the people pre-allocate the future because they assume that at some point they will get, they will be asynchronous to another machine, to whatever. So you do that up front because you don't want to break the API later.
So I think there with future is interesting thing because that's what I'm moving to with my language. Instead of this Erlang model of you can send and receive anything at any arbitrary time. Good luck trying to prove it with the compiler.
That's a lot of work.
You have to have session types, and they have their own bucket of problems. Basically, the biggest one, the lack of ergonomics. Like every paper I looked at, it's like, here's a simple session type for a ping pong thing, and it's like 2 pages long. You're like, yeah, nobody's gonna
surprise, surprise. We push more things into the type. Surprise, surprise.
But so the model I'm moving towards is one where your processes are essentially just classes that run summary. I call them async classes in the type system. I've kind of done away with the idea of process. That's more sort of a implementation idea. And they are fully isolated, but then their messages are method calls that are tagged as async. And then the people communicating with the process can only use async methods, and the process internally can only use normal ones. So you don't get this sort of cross-tanglement, whatever. But they use futures for communicating the results, but the futures are not actually allocated by the runtime. It's the compiler that says it will allocate a future, or specifically a pair. So it's just basically the reader and the writer. And then it will pass the writer as sort of a hidden argument to the message. So the benefit being there that if I can somehow determine, like, hey, the result is never used, then don't allocate a future.
Yeah, so you use the future to some kind of theory that it will maybe asynchronous or it will be asynchronous, but under the hood, the compiler just implement that machinery without allocating the future.
No, so let me type it out. The syntax is still sort of work in progress. Is fully decided yet, but let's say you do something like this is a little annoying in Zoom.
Yeah. You write it in your favorite editor and cut and paste.
Yeah, and then it messes up.
I think we have to experiment with some kind of whiteboard that we can all write and share.
Well, that's Google Docs. It's not a bad answer.
Yeah. No, okay. So I've left out any animated typo. I left out the implementation, but it's basically instead of just a normal class and a normal method, it's an async class and an async method. And async methods can only go on async classes. And there's some other restrictions to prevent deadlocking, or at least make it very difficult. When you stuff async in front of it, it becomes a message, like always. It's async.
But is it more expensive if you don't have right now an async need for async capabilities? Can you make that disappear in order to regular function call? If you don't use that async capability.
Oh, you mean you call an async function, but you want it to be used as a sync one?
Yeah, because like I said, you often use the async capabilities pre-front without actually needing yet.
No, so if it's tagged as async, it's async always. And that's because it's not futures like in, say, JavaScript, where everything runs in a single thread. It's futures as in there's actually a separate task running code in the background, and that thing may or may not finish long after you're done. And I guess with a sufficiently smart compiler, if you have a function, it spawns a process, it does its thing, and then don't use it.
Sufficiently smart here is that the thing you're calling is trivial enough to just inline it in place.
Yeah, you might be able to get rid of it, but even then, that might not be desired. Like if the workload is quite expensive, and for whatever reason you want that to be done in a separate thread, basically inlining that would be sort of counterintuitive at that point, because you say, hey, you thought you were going to spawn a thread, but actually we're not going to do that because I randomly decided to inline all of that away.
There's a separation of cost model from semantic. You say it's always a message, but what I'm hearing is the semantics are always a message. The optimizer always does what the optimizer does.
So if it's async, it is always a message. There's always a process backed behind it. The optimization is that if the result of that is never used, the compiler might at some point say, you know what, we're just not going to allocate a future, but the thing is still going to run async. It's just it writes its result to a black hole, basically.
Yeah, file write, background file write.
So does your system think in an event loop?
Like
are these things just getting thrown into a queue that will eventually get worked on?
Yeah. So in the old model was Erlang. You had a message queue. In this new system, it's still a message queue. It's a bit more strict. It's a first in, first out queue, guarantee that the order is consistent. And processes
globally FIFO across the entire system.
No, per process. So if I send 2 different processes a message, I might get those results in any arbitrary order. But if I send the same process 2 messages, say A and B, I will get them back in the same order. Because that process itself processes its queue in order, and it doesn't shuffle the messages around based on some heuristic or whatever. And that model makes it a hell of a lot easier to deal with a lot of things, but also to prove, like, hey, I sent it this message, I typed it as X, so I'll actually get back something that is of type X. Whereas in the Erlang model, you just say it's some random point of code receive message, and the compiler is like, I have no idea what the type is. Like, how would you know? And
well,
sorry, go ahead.
I think that's the typed channels that you should know, or you should get called. I mean, look at this from Elm doing this thing, and he always gets his types back. They're asynchronous, they come in any fucking order, but the types are always there.
Yeah. Yeah. So I do estimate like the term future here is a bit like a bit of a loaded term.
Yeah. Yeah.
Because different people mean different things, and some are like, no, it's called a promise, and semantics.
Yeah. Why did hacker
technically it's a single consumer, single producer, one-shot queue, I guess is the best description, because once a value is written, no value will be written again. But yeah, that's a bit of a mouthful to tell people, so I just like, Wikipedia, what's the best term? Oh, future. Okay, there we go.
Where's the shared code pad?
No, it seems a reasonable term to use, York, for what you're describing.
So I have to create an account. All right. Yeah, I think I'm going to try Google Docs next go around. I'll poke me and I'll make
like a reasonable first pass.
I'm sorry?
Let's try Google Docs, yeah.
Yeah, I don't want to have everyone have to sign up for HackerRank and then discover that the pad's no good in multi-threaded context. Google Docs, at least I know it's reliable with at least 2 people hacking constantly. We'll see what happens with 10 people hacking. That'll be exciting.
I think the record I've seen was 100 people in a doc, and the 101st person gets a warning that's like, you get a read-only view of this doc because, oh, come on.
It's really not a big number.
Fair enough. All right, yeah, it's late for me too. I'm gonna bail out here as well. It's been a good coffee compiler club. Till we meet again.
Next time, async and getters.
Oh God, I thought we beat getters to death already. Async's a rat hole that we could go explore. That's for sure.
I'll have a good future example for next time.
Yes, futures, another good example. All right, bye.
Okay, bye.